Hello everyone, welcome to my channel Physics Tricks. So in today's session we'll start with kinematics theory and problems. We'll quickly revise the theory and we'll solve some problems related to that theory. Okay, so mostly in this video I'll take formulas and based on that formulas I'll take some questions. Okay, so here we have first one, speed. Speed is nothing but distance traveled per unit time. So S is equal to d by t. So S is speed, d is distance and t is time. Average speed, we have total distance by total time. So types of speeds are there. If you want the video on basics, you can check the description and you can click on that link. You can have the basics of kinematics. Okay, so now in this video I'll just quickly recap everything. So average speed, total distance by total time. So over here for equal distances for equal time, what is the average speed? The average speed formula is V average is 2v1 v2 by v1 plus v2 for equal distances, and average speed formula for equal time is v1 plus v2 divided by 2. v1 plus v2 divided by 2. But if they gave other than this equal distance and equal time, other than that, how to solve? So see here, you have to go with the basics, nothing else. So as you can see over here, it is given a person travels along a straight road for a first t by 3 time and with speed v1 and for next 2t by 3 time with speed v2. That means person travels along a straight line, it is given, and for the time t by 3 it is traveling with the speed of v1, and for the time 2t by 3 it is traveling with the speed of v2. Okay, now, so we have to find what is mean speed, what is the average speed. Mean means what? Average speed. So average speed is equal to total distance travel. Let us consider d1 plus d2 is the total distance travel and total time required for this is t. So which is equal to what is distance? It is speed into time. So v1 into t by 3 is the distance plus v2 into 2t by 3 is the distance divided by time, and as you can see it is v1 plus 2v2 divided by 3. So what is the answer for this? v1 plus 2v2 divided by 3. Option 1 is the correct option for this question. So I hope this is clear. So the next question. A car travels at a speed of 80 km per hour during first half of its running time and at 40 km per hour during the other half. Find the average speed over here. Now here first half of a running time indicates what? Here time is same, right? So one train is there, or car is there which travels with a speed of 80 km per hour for the first half time and with a speed of 40 km per hour for the next half time. So you have to calculate what is called as the average speed, and I told whenever they give equal time you have to take the mean of this v1 plus v2 divided by 2. So 80 plus 40 divided by 2 which is equal to 60 km per hour. 60 km per hour. So I hope this is clear. Now the next question we have, and it is given a body traveling along a line traverses 1/3 of the total distance with a velocity 4 meter per second. The remaining part of the distance was covered with a velocity 2 meter per second for half the time and with the velocity 6 meter per second for the other half time. The mean velocity averaged over the whole time of motion. Now see, they might divide the problem in 3, 4, 5 terms, right? Over here it is given the total distance d supposed to be, right, and the body traveling along a straight line travels 1/3 of the total distance. 1/3 means this much, 1/3 of the total distance with a speed 4 meter per second. Now the other distance is traveled in the two intervals. First with 2 meter per second for the half time and then 6 meter per second for the other half time. Now whenever time is same, I told you can actually average this out. So throughout its motion, what is the velocity? Velocity we have is v1 plus v2, that is 2 plus 6, 8 divided by 2. So it is 4 meter per second. Now initial velocity is 4 meter per second, final velocity 4 meter per second. That means throughout its motion, the velocity is constant. As for the entire journey, velocity of the body is constant, that means uniform. Therefore average velocity we have is that constant velocity, and that is equal to 4 meter per second. So answer for this question we have is 4 meter per seconds. So I hope this is clear to you all. Right, so whenever they ask you to find out the average speed, average velocity, what you have to do, you have to just draw the diagram, total distance by total time. If they give equal distance, 2v1 v2 by v1 plus v2. If they give 2 equal time, v1 plus v2 divided by 2. So I hope this is clear. Now the next problem, right, now next one is based on the acceleration. So as you can see over here, what is acceleration? It is the rate of change of velocity. Right, acceleration is v2 minus v1 by t. v2 is the final velocity, v1 is the initial velocity, t is the time. Right, acceleration has some expressions. Acceleration is dv by dt, which is equal to dv by dx into dx by dt. Now what is this dx by dt? Rate of change of position, that is the velocity. So v dv by dx, this is also the expression for acceleration. So what is average acceleration? Average acceleration is total change in velocity in a total interval of time. Okay, now based on this we'll do some problems. As you can see over here, if a body travels with uniform acceleration a1 for time t1, okay, one body is given, it travels with a uniform acceleration a1 for time t1, and initial velocity is supposed to be u. Okay, so and it is given with uniform acceleration a2 for time t2. Okay, uniform acceleration a2 for time t2, that indicates what is the final velocity at this point. Let us consider v, and final velocity at this point let us consider v dash. Okay, so can we write a1 as v minus u, that is the change in velocity divided by time t1. So from this v minus u we can have is a1 t1. Okay, what is a2 then? a2 we have is v dash final velocity minus initial velocity v divided by t2. So from this we have v dash minus v is equal to a2 t2. Now tell me, what is the average velocity? Average acceleration definition. Average acceleration is total change in velocity, that means v dash minus u divided by total interval of time. Total time is t1 plus t2. So over here, as you can see, average acceleration is equal to, what is the total change in velocity? V dash minus u you want. So if you add this, you will get v dash minus u. So a1 t1 plus a2 t2 divided by t1 plus t2. So I hope this is clear now. This is the average acceleration which we have. This is the average acceleration which we have. Okay. So the next problem here, if v is the velocity of the body moving along x-axis, then acceleration of body is, see, acceleration is equal to dv divided by dt, that is rate of change of velocity we have, which is equal to dv divided by dx we can do into dx divided by dt. Indicates what? This dx get cancelled, we'll get the dv by dt only. But what is dx by dt? Dx by dt is rate of change of position, and that is nothing but the velocity into dv by dx we have. So I hope this is clear. So acceleration is v dv by dx. That is the one of the expression for acceleration. So from this we can say that if you want the acceleration, then you can multiply velocity. You can multiply velocity with what is called as a slope of velocity position graph. So acceleration is nothing but what? Multiplication of velocity with slope of velocity position graph. So this is also very important point. Do remember this. Okay. So the next problem, as you can see over here, a particle move with velocity v1 for time t1. Right. Okay, so a particle moves with velocity v1 for time t1. Okay, no problem. Then v2 for time t2. v2 v2 for time t2. Magnitude of its average acceleration is, okay, so what is the average acceleration? Average acceleration is total change in velocity. It is v2 minus v1 divided by total interval of time t1 plus t2. So I hope this is clear. It's very simple, right? v2 minus v1 by t1 plus t2. So I hope this is clear. I hope this is clear. This is the average acceleration which we have. Okay, so the next concept which we have, and that is the kinematical equations. Kinematical equations. So see here, there are three kinematical equations and one corollary for this three kinematical equations. First we have is v is equal to u plus at. What is v? V is the final velocity, u initial velocity, a acceleration, t is the time. S is displacement, u is initial velocity, t is time, a is acceleration, t is time. V final velocity, u initial velocity, a acceleration, s displacement. Nth formula, this formula will get from this displacement only, and that is equal to u plus a by 2 2n minus 1. So all these formulas are very important. Do remember this. Okay, now we can apply these formulas for freely falling body and for a body thrown vertically upward. So for a freely falling body, it's supposed to be one body is there, right? What is the initial velocity? It will be 0. So it will travel a distance of, or the height of, we can say, h. So at this point its final velocity is v. So this final velocity is minus g into td, because the time, what is td? td is the what we can say, the time of descent, right? Now time of descent. Okay, so what is time of descent? Time of descent is the time required for an object to move downward or towards the ground, isn't it? Whatever time required for the object to go till the ground, that is called as the time of descent. And s is equal to minus 1 by 2 g td squared. Same, v is equal to u plus at, s is equal to u plus half at squared, v square is equal to u square plus 2as. Everything is same. Now here only thing is whether the body is moving downward or whether the body is thrown vertically upward with some velocity. Okay, it will go till height supposed to be h. Okay, so whether the body is moving upward or it is coming downward, acceleration is always negative g. Why? Because I consider downward direction as negative, and acceleration, whether you are going upward or the downward, it is always what is called as the negative. Always what is called as the downward, and that is negative. So acceleration, whether you are going in the upward direction or in the downward direction, the acceleration direction will never change. Acceleration will always be downward direction. Okay, so these are the expressions which we have. V is equal to minus g into dd, s is equal to minus 1 by 2 g into td squared, v square is equal to 2g into h. So from this we can have the time of descent as v by g, which is equal to root of 2h by g. So likewise, if a body thrown vertically upward, at the topmost point velocity will become 0. At this point we have the what's called as the maximum velocity. So u minus g into t. T is time of ascent over here. Time of ascent. It is the time required for a body to go to the maximum height. So s is equal to uta minus half gta squared. 0 squared is equal to u square minus 2gh, and ta we have u by g root of 2h by g. If h is same, right? If h is same, we can have time of ascent is equal to time of descent. Indicates what? Indicates time of flight is 2 times time of ascent, or else 2 times time of descent, which is equal to 2u by g. So I hope this is clear. Right, now we'll do some problems based on this. It is given a body starting from rest with uniform acceleration 8 meter per second squared. The speed of body after 5 seconds will be. We want what is the speed of body after 5 seconds. It is starting from rest. So initially you need to understand the question thoroughly. Here, body is starting from rest, indicates what is the initial velocity? 0 meter per second squared, right? 0 meter per second. What is the acceleration given? Acceleration is 8 meter per second squared. Speed of the body after 5 seconds. Speed of the body after 5 seconds. That means t is equal to 5 seconds. What is the speed? That is v is equal to what? So we know that v is equal to u plus 80. V is equal to u plus 80. So v is equal to u is 0 plus a is 8 into t is 5. So we have, it is 40 meter per second. So v is 40 meter per second. So at t is equal to 5 seconds, we have speed as 40 meter per second. So I hope this is clear. Chalo, next problem. As you can see over here, the initial velocity of a car which is stopped in 10 seconds by applying brakes which produces retardation of 2.5 meter per second square. We want what is the initial velocity of a car which is stopped in time t is equal to 10 seconds and which produces a retardation. Retardation indicates acceleration as minus 2.5 meter per second squared. Okay, so over here, as the body or the car is stopped after 10 seconds, what is the final velocity? It is 0 meter per second. That is what you have to extract from this question right now. So over here, as the car is stopped after t is equal to 10 seconds, the final velocity is 0 meter per second. So by first kinematical equation, we have final velocity 0 is equal to initial velocity, and that is u plus a into t. A is minus 2.5 into t is 10. So we have u is equal to 25 meter per seconds. So this is the answer which we have, 25 meter per seconds. So I hope this is clear. Now the next one, a car moving with a speed of 54 km per hour stops in 8 seconds. On applying the brakes, the acceleration in meter per second squared is, okay. Now it is given initial velocity as 54 km per hour. Kilometer per hour as in 5 by 18, which is equal to 15 meter per seconds. Okay. So this is the initial speed. It stops in 8 seconds. What is the final velocity then? 0 meter per seconds. In what time? T is equal to 8 seconds. What is the acceleration? So acceleration we have is v minus u divided by 8, which is equal to what is v? 0. What is u? Minus 15 divided by time is 8, which is equal to minus 15 divided by 8 meter per second squared. Now they have asked the acceleration. Acceleration is minus 15 by 8, but what about the retardation? Retardation will be negative of acceleration, and that is equal to, we have 15 by 8 meter per second squared. So this a dash is retardation. So whenever they ask you to find the retardation, you have to consider the negative of acceleration, and whenever they ask you to find out the acceleration, so you have to find the exact value. So I hope this is clear now. So the next one, an object is projected upward with velocity 4.9 meter per second. Okay, so one object is there which is projected upward with a velocity of 4.9 meter per second. It will strike the ground in. Okay, so we want what is called as the time of flight. Why? Because it will go upward till the maximum height. It will go upward till the maximum height, and then it will fall back towards the ground. So whatever time required for its upward journey is the same time required for this ball during the downward journey. Then this is called as the time of flight. So time of flight is 2u divided by g. So which is equal to 2 into what is u given 4.9 and what is g given 9.8. So it will be 2 4.9s. So this get cancelled. What is the time of flight? So in 1 second only it will fall towards the ground, we can say, right? Or it will strike the ground, we can say. So I hope this is clear. Now the next problem which we have is a particle is thrown vertically upward. Okay, one particle is there which is thrown vertically upward. If its velocity at half of the maximum height is 10 meter per second. Okay, so if its velocity at the half of the maximum height, h by 2 supposed to be, and it is given 10 meter per second. So what is the maximum height reached? So what is the maximum height reached? So it is h by 2, it has to cover. So h by 2, that is the maximum height, half part, is equal to u square by 2g. U square is 10 square divided by 2 into g is 10. So as you can see, this two get cancelled. So maximum height we have is 10 meters. So this all questions are very simple. Chalo. Next problem. Now see, a particle is projected upwards with velocity 60 meter per second in 8 seconds. Okay, one particle is there which is projected upward with a velocity of 60 meter per second in 8 seconds. What will happen in 8 seconds? Okay, so see, what is the time of ascent? Time of ascent will be u by g, 60 divided by 10, so that is 6 seconds. Time of ascent is 6 seconds. That means that particle will go towards the maximum height, and in 2 seconds it has to travel back, right? It has to travel back. So I'll calculate what is the maximum height. Firstly, I'll calculate what is the maximum height. Maximum height will be 60 into 60, u square by 2g now. 2 into 10, 0, 0 get cancelled. We have 180 meter. 180 meter is the maximum height right now. So if maximum height is 180 meter, so what is the distance traveled by the particle in the 2 seconds from the maximum height? S is equal to half into 10 into t square, that is 4, which is equal to 20 meter. So in 2 seconds it will travel a distance of 20 meter. So from the initial point we have to consider the displacement for average velocity. Right now, displacement will be what is called as 180 minus 20, 160 meter. So first question they are asking is average velocity. V average is equal to the total displacement is 160 meter divided by what is the total time required for this 8. So you will get 20 meter per second is the answer for the first question. Okay, no problem. Average speed we want. What is average speed means? Average speed means the total distance traveled by the particle divided by total time. What is the total distance traveled? 180 plus 20, it will become what is called as 200 divided by time required is 8. So which is equal to 4 5s are 4 2s are, so that is 25 meter per second. So 25 meter per second, and it is given in option D. So I hope this is clear now. So all these questions are very simple if you go with the basics. So next, now it is given, find the ratio between distances traveled by the body in 5th second and 13th second starting from rest. This word starting from rest is very important in this question. So first one, starting from rest indicates u is equal to 0 meter per second. We want what is the displacement of or distances traveled by a body in the 5th second and in the 13th second. Okay, so S 5th we have is a by 2, 2n minus 1, 2 into n we have is 5 minus 1, so which is equal to 9a divided by 2. Okay, and S 13th we have, and that is equal to a by 2, 2 into 13 minus 1, so which is 25a by 2. So we want the ratio S 5th by S 13th, and that is equal to 9a by 2 divided by 25a by 2, and a by 2 get cancelled. We have 9 divided by 25 is the ratio. So I hope this is clear. Now starting from rest, next question. Starting from rest, a body travels 36 meter in 2 seconds. First 2 seconds. 36 meter in first 2 seconds indicates initial velocity is 0 meter per second. S is given 36 meter. Time is given 2 seconds. Can we calculate acceleration from this? Tell me. Yes, we can calculate. S is equal to half at squared. Why? Because u is 0. So S is 36, which is equal to half a into t squared as 4. So what is the acceleration in this case? It is the 18 meter per second squared. No problem in this. This is the acceleration. Okay. Now they want find the distance it can travel in the 11th second. In the 11th second. So S11th we have is equal to U0 A by 2 into n minus 1, which is equal to, what is A? 18 by 2. 2 into 11 minus 1, so which is equal to 9 into this 22 minus 1 is 21, which is equal to 9 ones are 9, 9 twos are 18. So 189 meter. This is the answer we have. So I hope this is clear. I hope this is clear. Now the next question. And in this, firstly we have the projectile motion. See, in projectile motion, these three formulas are very important. These three formulas are very, very important. Okay. Now, what are those formulas? See, we have what is called as a range. Range formula is u square sine 2 theta by g. Now, what is range? What is maximum height? And what is time of flight? I'll just explain in 2 minutes. So, if I just throw the ball at some angle, right? If I just throw the ball at some angle, theta, then this ball's trajectory will be somewhat like this, right? Okay. Then we have what is called as this use one component u cos theta, that is along the horizontal, and this use one component u sin theta, that is along the vertical. In horizontal direction there is no acceleration, but in the vertical direction there is an acceleration, and that is equal to g in the downward direction. And that is the reason this u sin theta will decrease till the maximum height, and after that it will increase till the ground. So over here, and over here, if I ask what is the horizontal velocity, you have to say it is u cos theta, because there is no acceleration in the horizontal direction. That means if body is at rest in the horizontal direction, it will remain at rest. If body is in motion in the horizontal direction, it will remain in motion unless and until external unbalanced force acts on that body. So this is u cos theta. This must be u cos theta. And if I ask what is the velocity at the topmost point, it is only the u cos theta which is present, and u sin theta will become 0. If I ask what is the velocity in the vertical direction, it is some value v dash, and here it has some value v dash, but in the downward direction on the same level. Okay now. So I hope this is clear. So what is the range? Range is the maximum horizontal distance traveled by the projectile. So this is the maximum horizontal distance traveled by the projectile. Then what is the maximum height? The maximum vertical distance traveled by this projectile. And what is time of flight? Whatever time required for this projectile to go from point A to point B. That is what the time of flight is. So range formula we have, the time of flight formula we have, and the maximum height formula we have. Now if you want, right, like projectile motion, you wanted to see it practically, right, like lab, right? So you have, right, one site is there, University of Colorado. So you have one site, and that on that site you will be able to like simulate the projectile motion. I'll just show here, just a minute. So as you can see over here, so you can take vector 1, and yeah, so see, you can actually change the angles, right? And over here, this is the fire button, this is the eraser we have, and you can adjust this initial speed over here, right? If you adjust it to 10 meter per second, and if I just fire this, then it will be somewhere here supposed to be, right? And if I just change the speed to supposed to be 20 meter per second, and if I fire, then it will have somewhat greater range. Now if I just change, this will be like 25 I'll do. Then if I just fire, then it will go to the maximum, right? And if I have supposed to be, if I wanted to see the components of the vector, so you just click on the components, velocity vector, then fire it, then you can see the components of the vector. And as you can see over here, right, see, initially the vertical velocity, I'll just make it slow. Now see, initially vertical velocity decreasing. At the topmost point it is 0, then it is increasing, and at the last point it will be what is called as the maximum, we can say, है ना? So if you wanted to see the simulation part, right, you can go to this site, right? And if you want, I'll just put this site into the description. You just click on that and you can actually have with the air resistance, without air resistance, what will happen. Now if I see without the air resistance, see it will actually be having the maximum range, isn't it? It'll what we can say, it will not have any air resistance, and it will go further and further, isn't it? See, and here the horizontal velocity will never change, but due to the air resistance, the horizontal velocity will obviously will change, as you can see over here, right? Horizontal velocity, due to the air resistance, it is changing. But if you consider air resistance as 0, then as you can see, the horizontal velocity will always be equal. It is due to the air, the horizontal velocity changes, but for us, the horizontal velocity is always remain constant unless and until it is mentioned in the question. So I hope this is clear. Now we'll switch back to our problems. Yeah. So these three problems are these three formulas are very important. Do remember these three formulas, right? One is u squared sine 2 theta by g. Second one is 2u sine theta by g, and third one is u squared sine squared theta divided by 2g. Now we'll do some problems based on this. Now it is given two projectiles are projected with the same velocity. If one is projected at an angle 30 degree and the other is at angle 60 degree to the horizontal, the ratio of maximum heights reached is, okay. So ratio of maximum height, h max, we have is u squared sine squared theta divided by 2g. So h1 divided by h2 is equal to the same velocity given, so u and 2g same, so you will have sine squared theta 1 divided by sine squared theta 2, which is equal to sine theta 1 as in sine 30 degree, sine theta 2 as in sine 60 degree, so which is equal to whole square. Sine 30 is 1 by 2 divided by root 3 by 2, that is the sine 60 whole square, so which is equal to this 2 will get cancelled, and 1 by 3 is the ratio of maximum height. So I hope this is clear. It's very simple if you understand the formulas, right? Chalo, next problem, as you can see over here. At the uppermost point of projectile, its velocity and acceleration are at an angle of. Okay, now if I just draw this graph, and in this, if I just throw the ball at some angle with respect to horizontal, what will happen? This ball will go and strike somewhere here, right? This ball will go and strike somewhere here. At the topmost point, if you see, velocity will be only in the horizontal direction, u cos theta, and the acceleration is only due to the acceleration due to gravity. So what is the angle between this velocity vector and the acceleration vector? As you can see, this is 90 degree. As you can see, this is 90 degree. So you can write the angle between velocity vector and acceleration vector at topmost point is 90 degree. 90 degree is the answer then. So I hope this is clear to you all. Now, if anyone has any doubt in any particular topic, they can comment in the comment box.